We're going to save some time. This is welcome to Summit Speed Dating. So the content switching between session is like really hard because it's only 30 minutes, and I'll try to do it even shorter, right? So you have to keep up with me. Welcome to our yearly session. Like every year, Red Hat is trying to bring you what's basically the latest in our platform, but also how we address current market trends, problems, challenges, the latest upstream innovation, and where we're driving forward as well, right? So we'll try to unpack all of it into our packed agenda. So we'll go over a recap, overview, if you will, of Red Hat's offering for OpenStack, which is now called OpenStack Services, and OpenShift, as it's integrated natively into Kubernetes. We'll talk about roadmaps, some notable features, zoom in specifically, as you saw from the title of the session, specifically today a topic of unpack what is Red Hat strategy, what specifically are we doing with OpenStack, with the AI strategy, and actually reality in terms of features, introducing our first generative AI assistant, integrated into OpenStack, and we'll finish with actually more of the interesting stuff, which is already applying it. Meaning, how can I already take the work we've been doing in LLMs and MCP servers and actually translate it in something meaningful you can do to reduce the time to detect, time to recover, improve your OpenStack operations going forward using AI assistants, Gen AI assistants, right? So this is pretty much our agenda for the next 25 minutes. I'll try to leave some time, so quick questions. I will be here after, and there's also semi-related sessions later that I'll point at the end. All right, so let's talk about our next-gen infrastructure. Those of you who are not familiar with Red Hat's offering to the market when it comes to OpenStack, we have 2 years ago basically modernized OpenStack from the ground up, right? Our first distribution for OpenStack was 2012, right, at Essex. And here we are finishing the Flamingo cycle, and we're already modernizing the platform. The mission has changed as well, right? When we started OpenStack, it was like we wanted to deliver a single experience of managing AWS on-prem, right? With open source technology. And now, who would have thought that 2024, 2025 was the year of virtualization again? And at the same time, we have more requirement from the platform to manage container native workloads on top and AI models. So the mission of change, and OpenStack needs to basically modernize itself, and this is exactly what we've done. So what you see here is we basically took all the operators we have in OpenStack, and all the services such as Neutron, Cinder, Nova, you name it, and packaged them already natively as microservice on top of Kubernetes and OpenShift, right? With all the lifecycle management. This actually allows us to do in the future things like, hey, instead of doing feature backwards to the platform from next releases, I can literally just replace the version of that microservice to actually a higher version while the others are independent. I can turn off specific microservices that I don't need. So if I don't use Swift, why should I even load Swift and just turn it off, right? So it's really, really moving to a microservice architecture. Some of the key benefits, there's a lot of benefits. You can actually now, bare metal wise, Ironic and Metalcube, right? You can actually have the shared repository. I can move nodes between OpenStack and Kubernetes and OpenStack. It's all managed in our OpenShift console. I'll talk about more examples of the unification, but high level, you can spin up worker nodes on RHEL, which is our traditional compute node, similar APIs, nothing changed on disk, but you can also spin up worker nodes, continue native workloads, or CNFs if you're in a telco space, natively on the same platform with same tooling, same Kubernetes already orchestration, and obviously opens the door to do things like CI/CD, GitOps integration with Argo CD, all of that, right? So you get all the benefits of the tooling while using this new architecture. So it's not just the technology or the tooling that I mentioned earlier. You get the unification. Some of our customers who use OpenStack are going from like government accounts, enterprise, telcos, right? And telcos specifically, OpenStack and Red Hat OpenStack specifically has become the platform for powering 4G LTE, right? And a lot of the same customers, service providers have basically either already onboarded 5G or in the process of going there. And 5G is all Kubernetes-based, bare metal, OpenShift in our cases, right? But having RHOSO, I call RHOSO, it's the short of Red Hat OpenStack Services and OpenShift, as a platform, which is unified based on Kubernetes, you can actually manage both, right? You see, so it's the same tooling as I pointed out earlier, but also what we see is a trend to centralize the teams and the skills. You have a team that now used to be only managing OpenStack and OpenStack APIs, now have OpenStack skills, and what we see is also a trend to unify the different teams and modernize the teams with SRE skills and DevOps skills and so forth, get more modernized. So it's not just the platform is being modernized, your teams are being modernized, right? To be able to deliver cloud native approach. And again, this also unified benefits when it comes to observability. Our previous stack for observability was, and I'll go to specific features, was based on a workload running in OpenShift to monitor OpenStack. Now in the next release, we basically integrated, it's the same observability operators that we run on OpenShift and Kubernetes that serves OpenStack, and I'll show you some examples. All right, I promised features. Let's see notable features. One thing that I mentioned, thanks to that move and adoption of modernizing platform with Kubernetes, now we're able to deliver features way more faster. So instead of waiting for the next major release that forces me to do an upgrade of an OpenStack release, sometimes RHEL release as well that goes with it, I don't have to wait, because Red Hat is bringing you new features roughly every 4 months. Similar to Microsoft feature packs, we have our feature releases. And in fact, these are available for the first few years of the product. I'll give you some examples. We just finished Flamingo cycle, and look at how many features, more than 100 features delivered since the GA last year of OpenStack 18, post-GA, right? Some examples that I highlight relate to AI specifically, and some of the features I'm going to highlight. Distributed zone is a new capability that we added. I'm going to have a slide on it. vGPU, live migrations, like across GPUs, that was actually added in the D release, and we brought it back into the A release. And the key thing about the feature releases, they're not disruptive to your running workload, right? You can basically operate and operate it, you get a new feature non-disruptively. So that's really, really cool. Thanks to the move into adoption of cloud native. We also add GPU with also subscription, VFIO SRV, GPUs for AI, and then things that's coming next month, right? Watcher, which I have a slide on it, which is basically Red Hat answer and open source answer to OpenStack for DRS, right? Many customers moving from Broadcom to here used to have DRS. I want something similar to that. There's actually a session about Watcher coming right after this session. And then we have OVN native BGP, dynamic NVMe, hot plug supports, a lot of new features, but again, a lot of them are being driven in the latest releases and brought back to the platform without any upgrade. That's the key point. All right, AI. AI is great, all the promises, but AI also brings headache, especially when it comes to security, right? Let's just look at the numbers, right? In 2023, between 2023 to 2024, right? We see a surge of 38% more, right? 2024 to 2025, more than 100%. I'll repeat, more than 100%. This is the cyber attacks that forces us to create vulnerabilities. So if you've been doing patches in your production system, you have a vulnerability, set one, you have to deploy, the volume has doubled. The volume has doubled, and it's going to become worse, right? So you need new ways to adapt to it, and obviously it's think about the frequent how many updates you need to consume and deploy in production. And the key part of it is like that can be avoided. And using live kernel patching is a critical component that enforced by us adopting AI, right? And it's not that we're adopting AI for our benefits. This is like AI being used by black hackers who basically use the tools today to look at your switch version and find all the exploits and then just launch a bot's attack on it to get access to your network, right? So, and this has been increased significantly, as you can see. So, I'm happy to introduce what our answer is, which is live kernel patching. That is now available only to OpenStack. It's not available in OpenShift, like with CoreOS. We're basically the first one to derive it. This is one of the big value adds of the latest OpenStack 18, because it allows you to actually apply these fixes live in memory to the kernel. So you don't have to evacuate your nodes, you don't have to use all this maintenance window just to move all the workloads between one region to another, so you can apply all the security patches without rebuilding the nodes, right? So really, really big improvement when it comes to operational experience related to the other side of AI, right? The dark side of AI, I would say. All right, I mentioned Watcher. Watcher is a very, very cool technology that exists in OpenStack for a long time. However, what we've done is actually brought it back and brought the investment back, but also modernized it. Watcher now is being deployed as a native operator microservice on top of OpenShift that allows you to actually have that smart scheduling to optimize your workloads, both for cost efficiency as well as performance improvement. Think about that smart schedule that can optimize performance and move the workloads on the fly based on different weights and action plans you can create. One cool thing that this capability brings, it opens the door to day 2 operations as well. I can leverage Watcher if I need to evacuate an entire region and do the live migration. I can use Watcher if I have a new hardware to introduce to my stack. So I have to move workloads to the new hardware, all of that can be orchestrated with Watcher. And in the future, think about this way, it's another smart scheduler we have that leverages other smart scheduler, which is Nova, which has been there forever. But now we can even leverage it going forward with AI, right? So it's really, really fundamental for going forward as well. So Watcher, there's a session right after this one with demos as well, so take a look at that. All right, I mentioned distributed zones. To those of you who have been monitoring Red Hat distribution, we had a long time our DCN offering, distributed compute nodes. Many of our customers run it at the edge. But what we've got is a lot of requests from enterprise customers. We don't have edge use cases, but we actually want to have more velocity when it comes to, I have different zones that I would, typically with low latency, so if I have dark file there, it can be a different room, different rack, different region, and I can actually provide the ability to orchestrate and deploy them with one OpenShift master domain and one set of OpenStack compute per domain, and leverage the all availabilities on functionality we already have. Right, in OpenStack 18, and we're already using multi-cells by default, right? This is one step forward. I don't even have to worry, imagine you're doing the cloud. This is almost like cloud with different regions. Think about Amazon, East, West, and so forth. This is a mini version of that using a single OpenStack endpoint, right? But it's split across different zones. There is a session upcoming as well at 3:35 on this session specifically, so feel free to check it out more. All right, as you saw in the keynote, we have introduced this week our VMware migration toolkit that allows customer basically to move workload using the open source framework of OS Migrate. We actually use it not just for VMware migration. A good customer asked yesterday, hey, can I use it from different OpenStack to OpenStack, either different distribution, do it yourself? Yes, you can do it. You can even use it for parallel cloud migrations between old versions. If you're like on OSP 13, we have still customers running on OSP 13, and I want to do the leapfrog all the way to 18, 5 major releases, you can actually use the migration toolkit for this. It's open source. We don't charge per VM as other tooling. This comes basically with the distribution of RHOSO 18, right? I put a QR code. This is coming in November release, which is another month, but the OS Migrate, all the documentation, demos, everything is already available, so feel free to look at that QR code. High level, what we're doing is we have a discovery mode. We can actually look at the introspect of your VMs before you do the move. We use changeback tracking, which allow us to do the worm migration from a source to destination. We actually can do live migration from live VMs of VMware, right? So this is another important point. We take care of the MAC addresses and network changes, all that stuff. The key part of the engine is actually leveraging Ansible automation platform that allows you to scale it. You can actually run it in scale, right? Think about some of the customers have thousands of thousands, tens of thousands, hundreds of thousands of VMs, right? You have to have a robust tool such as Ansible to allow you to do it in parallel. So it's already certified as an Ansible collection. You can go in if you have Ansible, start playing with it, and obviously it supports all the various guest OS. All right, you made it through the half of the session. Let's talk about AI. I'll start with our AI strategy. In very, very high level, right? And obviously we say Red Hat AI, you have so many products. I have OpenShift AI, I have RHEL AI, I have OpenStack as optimized infrastructure. What is Red Hat overall AI strategy, right? So in a nutshell, we have open platform of products and services that allows you to develop, deploy, manage, including lifecycle, scale your AI workloads including model training, inferencing, MLOps, all of that together across any footprint. All right, it doesn't matter if you're running on-prem, if you're running on public cloud, we can offer you this all integrated, and as you can see, it's also any accelerator, right? We have a saying, which is like any model, any cloud, right? And any accelerator. You can, this is what it means, open AI. Not the company, but actually open source choices when it comes to AI, which is represented on this side. So it provided that efficient capability, connecting data, agentic AI, and AI at scale. But in a nutshell, it's an enterprise grade. One of the big problems we have with AI is trust. Do you trust the models? Like if you're bringing any outsourced model, right? These come typically with a lot of good chunk of hallucinations, right? How can we trust the data we're running? If the data is not, if you don't have data integrity, this is all meaningless. AI is a very fancy tool to get answers to the data, but if you don't have data integrity and if you cannot even protect that data with confidentiality on your on-prem, then you don't have a solution, right? This is like the bare entry to get that platform. So, and this allows you to do private sovereign AI capabilities because we're doing the enforcements all the way down, right? It starts with the ground up hardware, through the kernel, through the hypervisor, through OpenStack APIs, through the OpenShift API that manage all the models, that allows you to run ML as a service and GPU as a service and all these capabilities, right? So it's a unified platform that allows you all these things. Last week, we actually made an announcement, which is our Red Hat AI Free that brings all these products we have under the same unified umbrella, which makes it easier for you to consume, faster way and flexible to scale inferencing with VLLM and LLMD, connecting models to data. We actually offer now a SDK that allows you to do data ingest, synthetic data generation, training improves to the RAG. Obviously, many customers started to do their own training, and then, we will go bankrupt because we cannot afford it. So obviously, a lot of customers now use their own data, but they use RAG to get it. So this is, again, all part of the framework, and what we're doing is actually working on it to integrate also partner integration to it. So we're opening it. Our LLM itself is also allowing you to bring your own data as well, so it's very open, right? By generate, and then accelerating agentic AI. We have our own, obviously, namespace, all the integration of various MCPs. Our goal right now in Red Hat is to make sure that all of our products connected, right? So there's a big effort for all the products in Red Hat will talk MCP. So when you do that question from your whatever LLM, I hope it's ours, but you will be able to get answers both from your own data, but from the Red Hat products, right, in real time. That's what we're bringing, all right? And then obviously I'm going to spend a long time on GPU and the servers and all that capabilities. Okay. Other nutshell, like I mentioned, like the stack. So the AI, Red Hat AI Free is basically what packaged all this up at the top, right? We have the VLLM capabilities, MLOps, distributed workload, pipeline scaling, all these capabilities, as well as all the things you need to run and do training and inferencing basically in the platform. And then, as I pointed out, we have all the hardware acceleration layer across every platform. So that's pretty much a standardized platform to run your AI enterprise grade with the security and confidentiality you need. All right. So let's zoom in specifically to OpenStack role. OpenStack is at the bottom, right? So we have all this ability to run and manage models on the top and serve them and lifecycle them and so forth. And like more than one model, obviously. And then we also have, we want to have the same experience whatever we're running, including OpenStack. OpenStack is our answer here, mainly to private cloud, but we also have customers who want OpenStack as a public cloud, specifically for sovereign cloud, right? Some regions today, you cannot move the data outside of the country, right? So we see a surge in OpenStack deployment offered as a public cloud for sovereignty. And it comes to managing hardware acceleration. We work natively to integrate the hardware accelerations with all the different vendors, but more importantly, we're adding our sauce to it, which is the management heterogeneously to the management. So think about it this way. If you run now NVIDIA, we support NVIDIA NIMs. You can actually run NVIDIA NIM with OpenStack VMs, right, capabilities. But what if I don't have NVIDIA NIM or I want to run the same capability with AMD or Intel and so forth? This is exactly the mission that Red Hat is taking to manage it uniform across the platform, right? High level, we offer integration, specifically features, as you can see. But the big thing is, think about all the management. Like I need to now to provide a specific SLA to a specific VM, right? Which is run right now at scale at production. So I don't want any other VMs consuming that GPU resource. I can actually guarantee that. I can have quota management. I can manage oversubscriptions of the GPU, right? All of these capabilities are offered here are done at the OpenStack layer, not at the GPU layer. Obviously, it's being offered with different vendors, like they do it vertically to their solution, but we do it horizontally across all of them. What about telemetry? I need to know what is the consumptions of each GPU. I need to know the metrics, the power consumption, all of these capabilities. And we're populating all of it in a unifying fashion into the OpenShift console so you see what's going on, right? So it provides that ability to do multi-tenancy for GPUs across different vendors with the management layer on top, right? So it's not just, hey, I can support GPUs, I need to manage these GPUs, right? That's where we're investing in the glue. All right, this is an example of the work we've been doing with NVIDIA and AMD. So we have an end-to-end delivery with NVIDIA GPUs. As I pointed out, we already added the GPU lab migrations. We support the NIM microservices. But if you don't want to use NVIDIA NIM, you can use Red Hat Inference Service, right, to do the same thing. We support the MIG-backed vGPUs inferencing for fine-grained allocations. And then AMD, you saw we added already FR1, the support for AMD GPUs with RHOSO. We can do in-stick GPUs with the ROC GPU IOV models. We have a tech preview SIRV specifically for telco service providers. And then we also looked at the ability to do slicing with 192 gigs GPU into multiple right-sized GPU, so you can actually slice it to a specific need. So the goal is like this way. I have one data scientist, right? Or a few data scientists. Every card is extremely expensive card, right? I need to now give the specific tenant a specific GPU access for a period of time to do inferencing or training and so forth. When I'm done, I need to tear it down and give it to another tenant. You see what data scientists. So this is literally GPU as a service with the platform, with multi-tenancy, with security. And again, as you can see, we not just certify with this partner, we co-engineers with the vendors to actually expose both of their functionality, as well as we add additional management with OpenStack to manage it all. All right, I promised LLM, we're almost on time. I'm glad to introduce our OpenStack integration with Red Hat OpenShift Lightspeed. OpenShift Lightspeed that we brought it to the world last May. It's basically LLM that allows you to run both of your data as well as other models. We support several of them. You can run it as well on both public cloud, Azure as an example, but you can run it on-prem. It's currently a developer preview, so feel free to start, kick the tires of it. And what you can see in this example, I basically asked the LLM, hey, what's going on in my NV configuration? I want to have a dual NIC support and so forth. So it will give you already meaningful data of how you can operate OpenStack, right? So it's not just OpenShift, and again, RHOSO 18, it's OpenStack Services running OpenShift. The same LLM can give you answers to both, right? It's like all the capabilities. All right, cool LLM, right? We saw a lot of them already. Let's move forward. All right, by the way, this is the walkthrough of OpenShift Lightspeed. If you want to kick the tires, check out the QR code. It basically allows you to get access, and it obviously has all the data you need just to run OpenShift Lightspeed. Now, some of the cool capabilities I mentioned are coming with integration. So here's our LLM, which you saw the picture earlier. But I want to use model context protocols, right? To actually connect more MCP service so I can bring more data to my user question, right? It can be both on OpenStack or OpenShift, but it can bring your own data. You can act your own data. So the same LLM can give you answers both on Red Hat products, but also on your own data, right? That's the beautiful thing. And using MCP, we'll be able even to go forward. So if there's other Red Hat portfolio, other products, or services that use MCP can natively integrate to the same LLM. That's the power of LLM plus MCP in a nutshell, if you will. Let's see an example, right? So one of the things my team has been working on the OpenShift side is actually incident detection. That leverages, surprise, surprise, machine learning, right? we actually look at incidents happening in your cloud infrastructure to allow you to ask simple questions such as, what's wrong with my cluster? Very general question, right? It will bring you the last incident that happened. It can be your application level, it can be a hardware level, it can be networking level, as you can see on the left side, and then you can even see what the alerts are firing, but also drill down within the LLM. You don't have to go outside, look at logs, look at metrics, look at traces. It's all brought to you within the LLM experience, right? That's incident detection using machine learning, already brought by Red Hat. I put the link to the blog so you can take a look at it. And we're looking to graduate at the beginning of next year, right? With the LLM, so cool capabilities. Another feature we're working right now is anomaly detection, right? I want to see what's going on and find me trends as well. Like we're going to see more and more capabilities. So that what's happening literally is the center of gravity move from the CLI, move some from your console, right, into the LLM. I don't have to go to 5 different places or look for documentation. The LLM becomes the centralized point for me to get answers from the platform, right? And then also do the debugging on the fly, root cause analysis on the fly within the LLM experience. All right, related sessions we have today. So there's more. I just gave you the menu today, basically. So we have the hands-on migration with our new toolkit happening at 2:10. We have the distributed zone as well at 3:55, and at the same time we also have the observability session with end-to-end. What the example I just gave you is more an observability use case, right? It just opened the door. All right, there's also some links. If you're new to OpenStack Services on OpenShift, here's the QR code for that. You can try Red Hat OpenShift AI, you can try Red Hat Inference Service. And again, I promised I'll keep you on time. Enjoy this summit. Thank you for attending this session. I'm happy to answer this question.